Welcome to this presentation of augmented and virtual reality for education and training. My name is Pontus Appelqvist. I'm the Vice President for the Asia Pacific market. I will do a short introduction and then we'll have Dr. Peter Looker, our Chief Learning Officer, talking about some implementation strategies. And finally, Jonathan Lee, our Senior Manager for Learning Technologies, will do a live demonstration of the AVR platform. So first, a bit about Eon Reality. We are a US company. We have about 10 offices worldwide, and we have 20 years of experience in R&D from developing AR and VR solutions for education and training. We also have built the world's largest network of interactive digital centers and VR innovation academies to further support different regions with the use of these technologies. As a company, we also have a very strong focus on education. The gentleman you see here is Professor Bertil Andersson. He is the former chairman of the Nobel Prize Committee and also the former president of Nanyang Technological University in Singapore, which was ranked #1 in Asia in 2018. He is heading up the Eon Education Board, which is focusing on advancing the use of augmented and virtual reality for education and training. And in this board and council, we also have several global experts, including Dr. Peter Looker, who is working with the team here to spearhead the use of these technologies worldwide. And to give you one example of how we work with universities, I would like to share this example from NTU in Singapore, where we have, together with them, set up an interactive digital center at the campus, where we provide both software, the platform, different systems for the purpose to use this for education and training, as well as for R&D projects with the local industry. We also hosted in 2019 April a global summit where we invited thought leaders and educational experts from more than 30 different countries. And I will play a short clip from this event where you can also hear some of the speakers present their thoughts on the importance of using these technologies for creating more meaningful learning experiences.
The key challenges we face in undergraduate training are the need to ensure our students have those foundational skills, and they need to be able to practice in a safe space. And the way of doing that in a realistic environment is using AR and VR technology.
Another recent example here is from UBT, the University of Business and Technology in Kosovo, Europe. So in the end of 2019, we launched an augmented and virtual reality center focused on the use of the AVR platform. And now, in response to the COVID-19 outbreak in this year, the university have decided to launch an initiative to create 20,000 learning experiences, or lessons if you like, through an activity-based learning program. This is spanning more than 20 different subjects and more than 160 courses in architecture, agriculture, engineering, and so on. And this is also one example where it shows not only the importance to provide a platform that's easy to use, but also where it's important to provide a methodology and a process and to onboard the faculty and the staff in the use of these technologies. And this is typically where we provide workshops with the staff, typically 2 to 4 hours, where we teach them how to create learning experiences on the platform. So in summary, for education, we do work with a lot of universities, polytechnics, colleges, vocational training centers, but also secondary schools and primary schools to provide education and training through the use of AR and VR and the AVR platform. We also do work with a lot of industry clients, and they primarily use our platform to deliver education, training, but also to assist workers on the job by providing them with guidance and contextual knowledge. And I will show you one example here from a company in Singapore, SBS Transit. It's part of a listed company, and they are managing some 3,000 buses here in Singapore and also part of the subway system. So what we have done here is to develop a set of applications that can be used both on iPads and smartphones to train the engineers and the workers, to make them familiar with the functionality of the engines, to have troubleshooting scenarios where they can study this on their devices. But then we're using the same assets, the same 3D models, to give them contextual knowledge on the spot while they are performing different service operations. And this is also where we can have remote experts dialing in and guiding the workers while they are performing their job through the use of this platform and these technologies. We also think it's important to point out that these technologies are not new, and there's a number of studies proving the value of using AR and VR for education and training. And one example here is from UNESCO, a report studying and evaluating the use of virtual reality in Africa for the purpose of deliver education and training. And I want to highlight the date, the year of this report, 2004. So already 16 years ago, we were engaging in the use of VR to provide knowledge transfer in Africa. A more recent report here from Harvard Business Review. This is studying the use of augmented reality in the workplace. And I think what's interesting here is not this number that you can increase performance with more than 30%, or 34% in this case, but that you can actually see this happening on the first use of the technology at the job. So with all these benefits we can see with the use of AR and VR, it's quite interesting to see that a lot of universities have in fact engaged in the use of VR in some shape or form, a pilot deployment. But 82% of these have not yet moved beyond the pilot stage. It's mainly used in a lab or in a separate faculty, not a volume rollout or deployment. And why is this? Based on our experience, we see three main reasons for this. It used to be a challenge to find relevant hardware. It used to be expensive, big and clunky to use. Today, this is no longer the case. You can actually use what you already have in your pocket or your hand, your smartphone, to deploy this. The second challenge used to be to find content, relevant applications and content that you could deliver for education and training. This is no longer the case. You can find thousands of applications today on the platform that you can either use as is, or you can modify them for use in your context. And finally, maybe the biggest hurdle in the past was the ease of use. You used to require to have programmers, very technically skilled users, content creators, 3D modelers, and even project managers to connect between the development and the subject matter experts, the teachers and the trainers. And this is no longer the case with the platform. Any teacher, any subject matter expert can create very meaningful and interesting AR and VR learning applications in a matter of minutes. And to give you an overview of the AVR platform, what we provide here as part of this platform is three different modules. The first one is called Creator AVR, and this enables you to use different AR and VR learning experiences on existing devices, on smartphones and tablets, for the purpose of delivering learning applications. The second part is the virtual trainer, and this is focusing on training and practicing, typically using head-mounted displays and headsets from HTC and Oculus, enabling students and trainees to step into a simulated environment and learn different procedures. And finally, we have the AR Assist component, which enables you to overlay information in a real job scenario. So in summary, the platform provides the different tools, the library, and enables organizations to manage content and applications in a safe and secure way. It's also important to point out that in this platform we do have a lot of content and assets, not only ready to use applications, but maybe even more importantly, you have individual assets that you can very quickly use for your own learning applications that we will see later on in this presentation. So typically how you would use this in a school or college or university setting is that you would have virtual labs on the campus, and this is where you would engage the students in more interactive, immersive lessons that can either be teacher-led or that can be experienced by the students. But you can also provide the same applications on the students' own devices at home or in other locations where they can experience this both in AR and VR. And we also support multi-user collaboration here, meaning that you can have groups of students logging in from different locations and together take part in different learning experiences through this platform. And with this introduction, I will hand it over to Dr. Peter Looker.
Thanks, Pontus. We're going to go on to a demonstration of how to use the AVR platform and how it might be used in terms of student learning. But first, I'd like to talk a bit about better learning with the AVR platform and some principles of student learning that apply to using the platform. I want to make two general points. The first is about the AVR platform and how it activates key teaching and learning principles. What I'm suggesting here is that we have all of these principles, but that the AVR platform can actually help to make it come alive. And the second thing is how EON supports individual institutions to implement the AVR platform. One of the things that distinguishes the last 30 years in terms of education is that there has been a very large amount of research into what makes for effective learning. And this overturns a few myths about the past in terms of student learning. We now know that, for example, students need to be actively engaged. If you look at the guidelines on learning that inform teaching that are mentioned on this slide, first developed at the University of New South Wales and used at other schools such as MIT, you'll find some research-based principles that are both research-based and also very practical. I've highlighted several of them here, 1, 11 and 13, because I think they're particularly relevant to the AVR platform on active, self-directed and independent learning with ICT, but equally most of the principles apply. Perhaps one of the most influential books on education to come out over the last 15 years is this one by John Hattie, Visible Learning. Visible Learning is based on 800 plus meta-analyses, 50,000 plus individual studies and 80 million students. Quite an impressive book. And what it's looking at is the effect sizes on student learning in terms of different sorts of approaches to learning on the part of teachers and students. Summing up the findings of the book, John Hattie says that the remarkable feature of the evidence is that the biggest effects on student learning occur when teachers become learners of their own teaching and, importantly for us in terms of the AVR platform, when students become their own teachers. We talk a lot about self-directed learning and the ability of the platform to embody self-directed learning. And here he's saying that when students become their own teachers, that's where some of the biggest effects come in. And also, one of the largest effects on student learning comes from self-reported grades. And I'd claim that both of these things are made possible by the AVR platform. Singapore is known to have one of the best education systems in the world. And the Singapore Ministry of Education quite explicitly encourages self-directed learning. I've cited two works here. One is a book that was published in 2010 that is based on the Singapore education system and what the Ministry of Education wants. And the second is a direct article from the Singapore Ministry of Education from 2018, which claims that a successful learner is a self-directed learner who takes responsibility for his own learning, who questions, reflects, and perseveres in the pursuit of learning. And I would claim that, again, these principles already exist. These are things that people want, and the AVR platform is able to fulfill this, at least to some extent. So how does the AVR platform help fulfill good principles of teaching and learning? First of all, students are able to construct lessons and explore subject matter, making self-directed learning easy. Secondly, there's the multi-user function, meaning that students and the instructor can collaborate in the same virtual space. This makes both peer learning and collaboration easy. Also, hands-on 3D can fill the gap between theoretical knowledge and application. This has always been a problem in education. That is, the difference between the theoretical knowledge that people learn in lectures and the actual application of that knowledge in the real world. We frequently hear employers complain about this in terms of students, and what I would suggest is that the AVR platform stands in that gap between theoretical knowledge and application. And it allows for more authentic assessment of performance, facilitating real-world kind of performance in terms of student assessment of skills. So when institutions engaged with EON, we have a 9-step implementation plan for self-directed learning modules with the AVR platform. So let's have a look here at a summary of the 9-step implementation plan. I'm not going to go into it in great detail, but to give you the kind of headline in the steps. Faculty and student training in using the AVR platform. Identifying 3,000 students or more to enroll in AVR platform accounts. Then developing learning outcomes and looking at the quantitative and qualitative criteria for students to meet those outcomes and to build lessons. Students doing peer review and evaluation of lessons, including self-review. And you remember how important that idea of self-review was from John Hattie's book. Students publishing and or sharing lessons and identifying and using the identified best lessons. As I remarked earlier, EON engages with each institution individually because each educational institution wants to do things differently. They've got their own learning outcomes, their own curriculum, and they differ from one another. And so what we do is to work individually with them in order to look at what it is that they need, and that includes a needs assessment in terms of the curriculum. I'll give you a couple of recent examples and try to explain how each of those is slightly different. First of all, the Los Angeles Community College, identifying uses for AVR platform in relation to nursing. So some of the questions that we ask in order to try to identify where the AVR platform can most effectively and best be used are some of these. What are all the sources of information normally required for a nurse to make a decision? What kinds of processes, instruments, machines, and so on are required to gather the data? Which of these can be simulated in AVR? These kinds of questions help us to get to exactly where the AVR platform can be used most effectively and how. At Al Akwain University in Morocco, we had a look at their engineering outcomes. So we're looking at 2 particular programs in engineering to implement the AVR platform. And we say, okay, so key learnings with the AVR platform are some of these. Not restricted to these, I'm just giving an example here of a few of them. Applying knowledge in real-world situations. So then we look at their learning outcomes and we find that there's one that says an ability to apply knowledge of mathematics, science, and engineering. So let's have a look at how those 2 things work together. Then there's authentic performance-based assessment, and we find a learning outcome that says an ability to design a system, component, or process to meet desired needs within realistic constraints, etc. And then there's one that says learning to visualize in 3D and at scale, and a learning outcome that says an ability to identify, formulate, and solve engineering problems. So the next stage then is to look at each of these, to look at where they're located within the curriculum, and to find how we can implement the AVR platform to deal with those points. And lastly, at the University of Business and Technology in Kosovo, we have identified 163 individual courses, or rather the university's identified 163 individual courses. What we are doing is looking at each of those courses, working with the learning outcomes in all of those courses to identify the AVR platform implementation, and to think very carefully about how the platform is best going to be used by students to develop lessons within each of those. Like I say, each of these is different because each university has different courses, and that's part of implementing the program, working with individual institutions to do so. And now I'd like to hand over to Jonathan, who's going to give you a very good demonstration of how to use the platform.
Hi there, my name is John, and today I'll be showing you how we can use the AVR platform for teaching and learning. The AVR platform is a web-based solution. As you can see, this is a web browser, and I've gone to the login page. So with an internet connection, a laptop or desktop, you'll be able to access the AVR platform anywhere. If this is your first time with us, you can actually sign up a free account by clicking here and using a email address, or you could use your Google and Facebook account to sign up as well. You'll be able to do most of what I'll be showing you today and even more in your free time. Okay, so I have my account. Let's sign in then. Because the AVR platform is a web-based solution, it means that you can actually access it across campuses, from home, in school, or within your institution. This is great especially for faculty members who are very familiar with using desktop applications, or even for students who are in computer labs. So as you can see, we are now logged in and we are in our library. The library is where you'll be able to see all your institution's lessons that have been made available to all users. We call that published lessons. You can keep lessons unpublished, and you can assign lessons to specific groups of users without needing it to appear in the library. Now the AVR platform supports two different types of lessons. We have the 3D lesson, which are lessons created from a 3D model, or 360 lessons, lessons created from a single or multiple sets of 360 photos. Both lessons will appear in the library, and you can toggle to search between the two. Now, let me demonstrate to you how easy is it for you to create a 3D lesson today, and how you could possibly use it for teaching and learning. So to begin, let's click Create Lesson. Now, if you're an institution or if your school is heavily on creating their own models, for instance, if you are an engineering school and your students create models, or you have your own models that you use for your training, you can actually bring in your models into the platform. Now in this case, I'll be creating a 3D lesson for this demonstration, and from here you notice we have two options. We could browse or import. Let me show you a little bit more about importing your models. From here, using our cloud conversion tool, you can actually drag in over 40 different types of formats of 3D or CAD drawings into the platform. And with our cloud converter tool, it does all the conversion for you. Even if your file, the software that you're using in the file output doesn't match this, it doesn't mean that it might not be able to take it. In fact, what we usually recommend to you is to send it to us and let us give it a try for you as well. By doing so, we help to improve the product further. But with the cloud conversion tool, just to show you an example how it would look like, here I have a zip file, and this model comes with multiple assembly files. I can choose which assembly file that I want to import in and click next, and that's all it needs. And that's all it needs to do. The cloud conversion tool will take over the next steps, and after that the asset will appear for you fully optimized for the AVR platform. Another way for you to bring in models in the platform is by using our Raptor tool. Now the Raptor tool works with Autodesk 3ds Max, and you can actually get Autodesk 3ds Max for free from Autodesk using an education license. Now why do we have this option? For advanced users where your model could be overly complex, where there are animations, or you require some optimization, Raptor will allow you and will highlight to you the areas that you need to optimize the model before uploading it directly into the AVR platform. So with the Raptor plugin, which is made available to all our clients, you can just download it, install it along with Autodesk 3ds Max, and you can begin using it straight away. That's how simple is it. Alright, let's go back. Now we've talked about importing your models. Let's choose the browse option this time. Now with all clients, for Eon Reality, we give them a set of assets to begin with. But because these assets are swath of different types, they covers different types of subjects, you may not always get what you want, or we may not have what you need. So let me show you an example of what we have done. Let's say I'm searching for a model on the heart, and I type the keyword heart here. I'll be able to see the models that are related to the heart within my library, and that's why they're called free assets. But what we have done is we've incorporated this thing called the Marketplace. Now the Marketplace is a way where with one search, you'll be able to search your institution library and also our partners' 3D assets. These 3D assets are sold on commercially, and from here you can actually see if there's any asset that fits what you require. So for instance, this model, when I click on it, I'll be able to see the cross section, the different breakdowns. I can see a description about it, and if this is a model I want, I can actually do a direct purchase here using credits that have been allocated to me. Upon conversion, this model will appear in my institution library. So let me clear my search and show you in another example. Right here, we have a section called Purchase Assets. These are assets that have been purchased through the marketplace. They have been converted and optimized for the AVIA platform, and now they appear here, and I can immediately begin using them. Now, for today's example that I want to show you is I'll be creating a lesson on the starter motor. So I type the word motor, and immediately, as you see, I don't have anything purchased before about it. I have free assets that come that's in my library already, which is one of it is the starter motor, and it also search the marketplace as well. In this case, I would like to use this model. Let's change the lesson name for this, starter motor introduction. Let's give it a category. I'm putting this under engineering, and let's begin building our lesson. So as you can see, the entire flow from the moment you log in to the moment you begin creating the lesson is really fast. You log in, create the lesson, click create lesson, choose the type of lesson and the model, and that's all you need, and you begin creation already. So here we go. This is our lesson editor, and now we have our model here. You can see the model is interactive. You can actually move this around, and this is great because when you play back this lesson later, you could use this as a substitute in your lectures or tutorials or even online sessions. Instead of giving students a picture or a video of the model, or giving them the raw file and asking them to load up expensive software that they might not have at home, by using the AVIA platform, they'll be able to see the same model from the comfort from any desktop or even their mobile device, which I'll show to you later. So you can see I can move around, I can zoom in and zoom out. We have some interactive tools here. Some of the highlighted ones are like the ability to explode the model to its parts, to bring up the annotations, so the different part labels. I can also double click to zoom in on the different parts as well. So for example, this one. So we do have some interactive tools that come default with any 3D lesson you create. Now, for any lesson that we do, let's create an introduction to the lesson. So as you can see, there's a default item here, which is called introduction. Let's create an intro. So by clicking on this person icon, I can actually do a narration, and there are two types of narration I could possibly use. I could use a text to speech, or I could upload an audio file. So if you have been doing lectures or you have recorded lessons and you have really good audio, you could actually extract that audio parts and upload it as an audio file, and that can be your introduction narration or for any part during the lesson. In this case, I shall use text to speech. It brings up a dialog box, and so since I have already scripted what I wanted to say, let me just paste my text here. And you can also change the language and region. Now for our text-to-speech feature, we do support multiple languages: English, French, Chinese, German, Portuguese, Spanish, Italian, Korean. You just have to type your text here, choose the appropriate language. In this case, I'll just stick to English, US English, and choose a voice and click synthesize. And let's click play just to hear it back.
A starter, also self-starter, cranking motor, or starter motor, is a device used to rotate, crank, an internal combustion engine so as to initiate the engine's operation.
Okay, so that sounds good. So once I click OK, that's it. My introduction is completed. You can always go back and re-edit it at any point in time. Now we have a second icon here that allows us to attach videos that are pertaining to this topic. So in this case, what I'm going to do is I have a YouTube video that I'm going to paste the link here, and I just have to click OK, and that's it. And so later when the student plays back the introduction or any part of the lesson that has such media attached to it, they'll be able to use this as part of supporting materials that could aid in their learning. So I've completed my introduction. Now we can also do other things, like for instance, if I call up the labels here, you see that every part is labeled, and I can use these parts as a learning point or lesson. So I'm going to do a lesson on the plunger. So I just have to click on this plus sign, and again I can use the text to speech or the narration and such and create a second set of second learning experience or points. We also do have some activities here, like build activities to put the model together. Maybe perhaps I shall, just by clicking done, that's it. So the student would just have to build this engine together. We can of course adjust the time as well if we need to. We have locate, which is to search for a particular part, to identify, to name a part, and of course the most basic multiple choice quiz. One of the other features, because we're using a 3D model, and later we'll explore the augmented virtual reality component of this, is the fact that we can actually interact with the model. So for some of faculty out there who are very familiar or very used to using Wacom tablets to doing lecture recording or screen captures, this tool will be really familiar to you. As you can see, there's this huge red record button here. By clicking on this, it will capture my voice and my interactions with the model, and that in itself can be a lesson, learning part of the lesson. So for instance, I can use this, and let me just show you a quick example of this. Welcome class, this is the lesson about the starter motor. As you can see, this is a standard starter motor. The design may vary from device to device, but the fundamentals are the same. You can see that it is consisting of two parts. On the top there's a plunger, and the bottom where the magnetic coils are. Now let's see how many parts are there in the starter motor. And today we're going to focus on the plunger. So as you can see, the plunger consists of multiple parts. There's a spring, there are windings, and this is where the plunger contracts. So what I've done is I've done a quick screen recording. Now when I click playback, welcome class, you will be able to hear my voice, and you will see where my mouse was hovering over the model. It will capture all my interactions and all the different manipulations that I've done with the model. I can also switch the view from a first person to a third person view, and the other way around as well. So this is a first person view, and this is where the student will be able to see from the lecturer's perspective about the as he or she explains the model or the lesson. And this is playable both on the desktop and mobile as well. So it's instant recording. So let's click save now. We have created a few things here. We've given an introduction, we came out with activity, and we did on-screen recording. Let's click save and see how the student will see this lesson on their device. So let's exit from here, and let me bring up the page here. So here you can see this is the desktop view of this. Of course, as the teacher, you'll be able to continue editing the lesson. You can play back the lesson as though you're the student, and you could also launch this lesson in VR. So what does this mean? With every lesson, 3D lesson you create on the AVR platform, with one effort, you'll be able to play this lesson on multiple different outputs. And one of them is using desktop VR. We call this virtual trainer. So if you have a Steam VR headset connected to your computer, you can actually play this in VR. And let me just show you an example of how it looks like. So this is a simple 3D lesson. By clicking launching in VR, it will launch our lesson player, and on your Steam VR headset you will see something like this, where you have your lesson, the model that you've chosen, and everything will play as though it is like what you had designed it to be. You will have your videos, you have your text to speech, you can interact with the model, you can break it apart, you can zoom in on certain parts, but the experience is so different. But you'll notice that all you need to do is just to create the lesson just once. Alright, now what I'm going to do now is I'm going to pull up my mobile phone. Okay, let me just drag my phone over. Okay, great. So as you can see, this is my mobile phone. I have this app called Creator AVR. So Creator AVR is a mobile app available on iOS and Android. It works on tablets as well, and this is how we interface with the AVR platform. So by launching it, you'll see that the first page you enter is actually the library, and it looks again very similar to the AVR platform login page as well. So let's sign in. Now, if you already have your account, just use the same credentials. So in this case, it's using mine, and that's it. You're logged in. Now, because in this instance, I'm the one who authored the lesson, I can go to my workspace and look under authored. Now, if I'm a student, you could assign the lesson to the student, and he'll find it under enrollments. So let's go to authored. Let's find that lesson that we created just now, which is the starter motor introduction. Fantastic. As you can see, it syncs really fast, and that's why the AVR platform is so good, especially when you're working with students remotely, in class, out of class, during lockdown. It makes it really easy to make everything accessible to them. Now, because I'm the author again, I have this extra button here, and this is the edit button. Whatever I create on the desktop, I can continue editing the lesson on my mobile device, and it just all synchronizes. We also do have a collaborate mode, which allows us to invite multiple users to join in, where we can discuss over the model. With the built-in VoIP, we can all interact and also speak to each other in a virtual room, and so that helps to allow you to have collaborative learning, not only just individual self-directed learning. Alright, so let's click start lesson and see how does this look like. As this is the first time it's loading, let's give it a few seconds for it to load on the device. Alright, great. So we have our model. As you can see, I can still interact the model. You can pinch in, pinch out. And let's see our introduction that we created.
A starter, also self-starter, cranking motor,
Great.
or starter motor.
So the introduction plays well. Let's take a look at the video then. So this is loading directly from YouTube in this case. Let's give it a second.
Welcome back. Today, a real treat. The starter motor. These are all the parts of the starter.
So as you can see, the video could be complementary to the learning, and it helps aid the learner, or you can even direct the learner to play the video before moving on to the next stage of the lesson. Let's take a look at how the on-screen recording played back. Welcome class. This is the third person view. The starter motor. I can actually still move around, I can pinch out so that I can see the entire model. And I can toggle to the teacher's view, the first person view. You can see that it is consisting of two parts. So as you can see, this is all live and it synchronizes almost instantly. Okay, great. And let's do that one quick activity about the build activity. And I hope I get this right. Okay, so we have different parts. Let's quickly build this together. I have 30 seconds. Oh my goodness. Not sure that I can make it in time. Let's try. Great. I'm doing quite well this time. Whoops. Alright, I did it. Great. So as you can see, it's really interactive and great. One of the key things here is that when you do teaching, whether you're in the lecture hall or you're doing remote teaching like I suggested earlier, you could use this as a substitute. And this is great because it's interactive. So as you teach the model, you'll be able to actually pull the model apart and focus on its different components. So in this case, let's say I want to focus again on the plunger. I can just double tap on the plunger, and now I have focus on the plunger. Okay, so this is great. So if you notice now, we have two new buttons. We have this word AR and VR. Any 3D lesson you create today will automatically come with these modes built in. So let's tap on AR. We use this feature called Markless AR, and Markless AR allows us to drop this model anywhere as long as a flat surface. So let's say I have this, and now I can actually see the model. Let's move to the starter motor, like as though it's there. As you can see, I'm actually moving around it right now. And because it's markless, we could also use our finger to rotate it instead of moving physically. And we can also scale it up. Now this is great, even for non-engineering subjects or non-STEM subjects. You could actually use this feature to bring students to places like, let's say, the Eiffel Tower, or to show people things at scale. By using a markless here, they can scale it up and they can physically go closer or walk even through the environment. And with all this, we still have the same interactions. Like if I want to explode the model and learn its different components and parts, I can do so as well. So this is great. Let's go to VR now. Now, if I type on the word VR, we actually go to a VR mode. Now, in VR, we actually recommend and we use this pair of mobile VR glasses. So as you can see, it slips on to the front of the phone, and then when you bring it up to your eye level, it will become a single image. So let's go back to that VR lesson. Okay, so now we are back in VR mode. As you can see, I can actually navigate the model by tilting my device. I can also aim to the eyes in the sky. That changes my perspective. And I also have other interactive features, just like in the regular touch mode or AR mode, where I can explode the model just like that. I can, as I point at the different models, it will tell me the names and the different parts of it. And I can go into orbit mode, which allows me to have a full 360 experience of the model from all angles, just by moving my mobile phone around. So you have mobile VR as well. This is great and useful for particular lessons, especially when it requires a lot of concentration and focus on the of the model at hand. So let's come out touch mode. So what you have seen now, with a single effort, you're actually able to play this model, this lesson, on your desktop, on a VR headset, on a mobile phone, mobile AR, and mobile VR, all through one-time effort. Now, one more feature that I want to show you is actually our 360 lesson. Now, I've already prepared a lesson beforehand, which is called Gardens by the Bay. This is from Singapore, and all you need to do is click Start Lesson. Now, a 360 lesson can be played on a mobile device or the desktop as well. As you can see, this is a full 360 immersive environment. Can move around. I can attach, I can label certain key areas, and I can attach a media or even an audio narration to those sections to become learning lessons. Now, because it's a 360 lesson, we can have multiple photos. So by clicking on the arrow, I can actually go to the next area. And again, this is the super trees in Gardens by the Bay. Now, on top of the learning essence of this, we can also load this in VR mode, which allows us to see this in immersive VR, again using the VR glasses that I showed just now. For example, if I point here, I can actually see the video being played in a window.
Special SG50 version of Garden Rhapsody. Watch the circuitries come to.
Now the learning modes here is that not only can I create audio narrations and attach videos, I can also have a quiz mode by clicking on quiz. And so I'll be able to put key points where I want to test the learner's understanding. And this is great for immersion. You can use this for lab safety, for humanity trails, social sciences, for school orientations. So what function does not describe Super Tree? The answer is using speakers. And it's as simple to do as just like a 3D lesson. Really immersive, really very cool. Okay. So with that, I've shown you some of the key features that you could use for teaching and learning, regardless of the subject that you teach. I hope that you will sign up for a free account, or if you already have an account, explore more of the features here that I have not covered. And hopefully this helps you to include augmented and virtual reality into your teaching and learning and enhance your learners' learning experience. Thank you.